Right, here's some help on similarity. Question 2 on MyMaths. You might not come across this setup, but if you do, I think it's quite tricky, so I've just done you another video. So, in that situation, which I've also drawn here, you can match angle A against this angle down here in the triangle, because the two lines are parallel, the horizontal lines are, and these two angles are called alternate angles. Okay? What you then know about the angle at the top here, that it must be 90 minus A. You've got a 90-degree angle at the bottom here. These two add up to 180, so if that's 90, the top one has got to be 90, basically between this vertical line here and the two horizontal lines, the parallel lines. So that one is a 90 minus A. What that in turn means down here is, if that one is A, and I've got a 90-degree angle in my triangle here, then surely that one must be, since angles in a triangle add up to 180, 90 minus A. What that then means for the two triangles is that actually all the angles in the triangle are the same, because you've got they both got a 90-degree angle in one corner. They've got an angle called A, and they've start on this side. They've got an angle called 90 minus A in one corner, which must leave them with an A down here and an A in this corner here, so that angle there. That explains why, for the question up here, why are the two triangles similar? Because the corresponding angles are congruent. All the angles that match up, so are corresponding within the triangle, are congruent, are the same size. What did I use to determine this? I've used alternate angles right at the start, and this thing called complementary angles here at the bottom, which are angles that add up to 90 degrees. Like we've done this here, is 90 minus A business. Okay? Right, and then you still got to find side X and side Y. Side Y being up there, side X being here. Go back to the picture. And you're going to be really careful now. The two sides that actually match are, I know they're drawn to be here, but it means that the 36 and the 67 match in those two triangles. So these two are linked, 36 and 67. And since the sides I'm looking for and the smaller of the two triangles, I'm looking at 67.5 has been multiplied by something, so times by x, to make 36. I just solve this by dividing by 67.5 on both sides. The calculator gives me a nice fraction, 8 over 15. And that is my scale factor from the bigger triangle down to the smaller one. You therefore take the side that was 36, which is actually there for the y, and times 36 by 8 over 15 leads to 19.2. And then you take the side at the very bottom, right here, 76.5, which will be the side x there, times it by the scale factor, which was 8 over 15. Go back to there. And you get the two measurements. If you're then a little bit smarter than I am and type them in the right boxes rather than mixing them up, you see MyMaths isn't happy with me because I should have put them in the other box. I've just muddled that up, but the numbers are correct. That's how you solve this trickier question with a really tricky setup of these two triangles. I hope that helped. Send me an email if it didn't, and I'll try it again. Bye!